Good afternoon. This is Fadwa from the University of Manchester Group 1 for the IMechE Design Challenge, and today we'll be presenting our presentation. The first part of the presentation will introduce the design challenge and our device. The main objective of this year's challenge is to design and build an autonomous device that moves, hits a wall at a non-determined distance, and goes back to the exact same position. We kept in mind four main factors when designing our vehicle. First, it must complete the task within 2 minutes, as well as the importance of precision, and this is why a pointer was always placed pointing downwards, as well as the size constraint of it being 400 millimeters for length, width, and height. When designing our final device, we kept in mind three main factors. First, we used 3 wheels instead of 4 to reduce price, and our distance measurement system comprised of belts and pulleys. And finally, we tried to minimize the use of materials as much as possible.
The steps taken by our team can be seen in the following Gantt chart. First, we had many initial ideas and we drew sketches for each one of them, but at the end we decided to stick to the gear idea. After doing all the calculations we needed and designing the prototype on SolidWorks, we purchased all the items and manufactured all the parts that we needed. We built the final prototype and tested it, and finally, after evaluating our vehicle's performance during the university round competition, we decided to do some modifications to the device in order to improve its precision and limit cost for the regional tournament.
So now I'm going to talk about the principal features of the final design. And this is the final design of our chassis. It is made out of aluminum because it is lightweight. And we made it a shell shape. And then we bent the sides to enhance the strength of the chassis. And for the final design, we used three switches: the on and off switch, the DP-D2 switch to change the motor or the vehicle's direction, and we also used a kill switch, which is a temporary off switch. And based on the task requirements of the challenge, we chose a motor that has a 37 RPM, and the wheels are 40 millimeter in diameters, and we manufactured them using aluminum. We reduce the diameter of the wheel to reduce the cost and reduce the weight of the wheels also. And at the end, using the motors and the wheels, we have the vehicle speed of around 0.0775 meters per second.
So now I'm going to talk about another important feature of our final design, which is the distance measuring system. We set up the gear ratio between the motor and the gear to be 1 to 40, and we allowed the gear with the button pusher to turn up to 315 degrees. So the vehicle would be able to run more than 4 meters. And how it works is shown on the screen. First, we calibrate the button pusher to be touching the kill switch. And as the vehicle is going forward, the button pusher would rotate away from the kill switch. And as it touches the wall and starts going back to the starting point, the gear would turn the other way. And then as the vehicle reaches the starting point, it would push the kill switch and stop the vehicle.
Now I'll talk about the engineering science behind our vehicle. The two main calculations that we did were the task complete time and the maximum distance that the vehicle can travel. For the maximum distance time, we calculated a time of 103.2 seconds, which is less than the 2 minutes that is provided by the competition's restraint. The maximum distance the vehicle can travel, we calculated a distance of 4.398 meters, which is more than the 4 meters that the competition states. The three features that we used to improve the accuracy of our vehicle was making the chassis as long as possible, using O-rings on wheels for the tires to improve grip, and manufacturing our wheels to fit our vehicle so that they are precise as possible.
For the final part of the presentation, I'll be discussing the cost of our device and its influence. As for the three main parts of the device, it can be seen that the mechanical structure is the most expensive, costing about £21, which is more than half of the budget. This is expected because it comprises of the chassis, the drivetrain, measuring system, wheels, and shaft. Next, it is the electrical components, and finally, the fasteners are the cheapest of the three parts. This brings us to the end of our presentation. Thank you for listening.